Hi everyone, my name is Sakit Raj Kolar, and I'm a student at Emerald High School in Dublin, California. Today I'm presenting our research paper titled Assessing Bias and Personalization in LLM Generated Nutrition Plans for Teen Athletes. And I worked on this with my mentor, Lavanya Prahalad. So the big question we started with was, if a teenager uses ChatGPT to get nutrition advice for their sport, how good is that advice actually? And more importantly, is it fair for everyone? That's what this whole study is about. Let's get into it. I'll start with why we even thought this was worth studying, then walk through our research questions, how we set up the dataset, the methods we used, the rubric we created to evaluate things, and then our results, which I think are pretty eye-opening. I'll finish with what it all means and where research like this should go next. I'll try to keep things clear and move at a good pace. We have a lot to cover, so let's go. AI tools such as ChatGPT are now widely used for health and nutrition advice, and recent studies suggest that they can generate meal plans that appear comprehensive and personalized. However, teen athletes represent a unique population with nutritional needs that differ substantially from those of the general public. They are simultaneously supporting growth and development while meeting the demands of athletic training, and their dietary recommendations must also account for factors such as cultural preferences, food accessibility, school environments, and budget constraints. This raises an important question. Are AI-generated nutrition plans truly personalized for teen athletes, or do they simply provide generic recommendations that appear individualized on the surface? In a preliminary pilot study, we found evidence that ChatGPT often produced recommendations that looked tailored but lacked meaningful adaptation to the athlete's specific circumstances. These findings motivated the larger and more systematic study presented here, which investigates the extent to which AI-generated nutrition advice reflects genuine personalization across diverse teen athlete profiles. We organized our study around 5 specific research questions. The first one is about physiology. Does the model actually adjust for things like age, body size, and how hard someone trains? The second is about culture. Does it recommend foods that actually make sense for someone's cultural background? Third, does it handle dietary restrictions properly, like if someone is vegetarian or lactose intolerant? Fourth, is the advice realistic? Does it assume you have a full kitchen and unlimited money? And fifth, if we give ChatGPT extra instructions about school schedules and affordability, does it actually do better? Our study had 2 stages. The first was a smaller pilot with just 12 personas. I wanted to see what kinds of patterns showed up before building something bigger. In that pilot, I already saw ChatGPT defaulting to Western foods and protein-heavy meal plans no matter who the person was. So for the main study, I scaled it up. We used 72 synthetic teen athlete personas, meaning we made them up in a controlled way, not real people. For each persona, we generated nutrition plans under 2 different prompts and did that twice. So in total, we got 288 nutrition plans to evaluate. The model we used was ChatGPT 5.5 with reasoning turned on, and we kept everything consistent so the results would be comparable. To evaluate personalization in a systematic and unbiased way, we created athlete personas that varied across 7 key dimensions. Age was set at 13, 16, or 18 years old, and gender included both female and male athletes. We also represented 6 cultural backgrounds: South Asian, Hispanic Latino, East Asian, Black African American, Middle Eastern North African, and White American. In addition, personas differed in body size, sport, training intensity, and dietary preferences. Sports included soccer, basketball, swimming, track and field, tennis, and cross country. Training load ranged from light to moderate to heavy, while dietary preferences included omnivorous, vegetarian, vegan, and lactose-free diets. By systematically varying these characteristics, we created a diverse and realistic population of teen athletes. This allowed us to examine whether ChatGPT genuinely adapts its recommendations to each athlete's unique profile, or whether certain factors receive more personalization than others. We used 2 different prompts for each persona. The baseline prompt gave ChatGPT only the core persona information: age, sport, cultural background, and so on, and asked for a realistic nutrition plan for a school-going teen athlete. The context-rich prompt added extra details, things like having a long school day, limited time to cook, needing affordable and portable foods, and being culturally appropriate. The idea was to test whether giving the model more context would actually improve the output. Each persona got both prompts, each generated twice in separate sessions, so we could check for consistency. After generating all the nutrition plans, we analyzed the results across 5 key dimensions: prompt type, cultural background, dietary preference, body size, and training load. Our evaluation went beyond numerical scores. We also conducted a qualitative review of the meal plans themselves to understand how personalization was being implemented in practice. We examined whether the same foods and recommendations appeared repeatedly across different personas, whether cultural backgrounds were reflected through meaningful and authentic food choices rather than superficial substitutions, and whether practical factors such as school schedules, food accessibility, and daily routines were adequately considered. By combining quantitative scoring with the detailed qualitative analysis, we were able to gain a much deeper understanding of the strengths and limitations of ChatGPT's personalization. This approach provided insights that would not have been visible from average scores alone. To evaluate the 288 nutrition plans, we developed a 5-dimensional assessment rubric. 3 independent human annotators reviewed every plan and assigned scores for each dimension. Any disagreements were discussed and resolved through consensus to ensure consistency across evaluations. The rubric assessed 5 key aspects of plan quality: personalization to the athlete's profile and dietary requirements, cultural appropriateness of the recommended foods, nutritional soundness, safety and age appropriateness for adolescent athletes, and practical feasibility in a real-world student-athlete setting. Practicality included factors such as food accessibility, preparation requirements, cost considerations, and compatibility with school and training schedules. Each dimension was scored on a 5-point scale, and all the dimensions were weighted equally in the final evaluation. It's important to note that this study does not provide clinical nutrition advice. Instead, the goal is to examine patterns in AI-generated recommendations and assess how effectively and fairly the system personalizes nutrition guidance across diverse teen athlete profiles. One of the clear findings from our study was the difference in performance across evaluation dimensions. ChatGPT performed exceptionally well on nutritional adequacy and safety, with both categories scoring above 90%. This indicates that the model has a strong understanding of established sports nutrition principles, including the importance of carbohydrates, protein, hydration, and overall nutritional balance for adolescent athletes. However, performance was substantially lower in areas that require deeper contextual understanding. Cultural appropriateness received a score of only 61.3%, while practicality scored 66.5%. These lower scores suggest that although the model can generate nutritionally sound recommendations, it often struggles to adapt them to athletes' cultural background, everyday food environment, and real world constraints. This slide shows the most important finding of the entire study. Look at the cultural appropriateness scores broken down by background. White American personas scored 99.6%, basically perfect. South Asian personas scored only 45.4%. That's a 54-point gap. When I dug into why, the pattern was clear. ChatGPT treats white American eating as the default. For every other cultural background, it would sometimes swap one ingredient, but the overall meal structure was still very Western. That's not real cultural adaptation. And when we tried the richer prompt to fix things, cultural scores went up a tiny bit, but practicality actually went down. Adding more instructions made the plans more elaborate and less realistic for actual school day. Prompt engineering alone is not the answer. The key takeaway is this imbalance in performance. ChatGPT demonstrates strong knowledge of physiological and nutritional requirements, but it is considerably less effective at incorporating cultural relevance and practical considerations into its recommendations. In other words, the model understands what athletes should eat, but is less successful at tailoring those recommendations to how, where, and within what cultural context athletes actually live and eat. When we looked at dietary restrictions, the picture was similar. The model recognized that someone was vegan or vegetarian. It didn't just ignore the label, but it didn't fully redesign the meals. Vegan personas often got a plan that looked like a meat eater's plan with the meat swapped out. Vegetarian plans still centered around protein in the same structural way. And lactose-free personas sometimes got recommendations that included yogurt without specifying a lactose-free version. So the restrictions were acknowledged at a surface level, but the underlying meal logic didn't really change. So what do these findings tell us? One likely explanation is the training data behind large language models. Sports nutrition principles are widely available online, so ChatGPT has learned those concepts very well. That's why it performs strongly on nutritional adequacy and safety. However, culturally specific food practices and the day-to-day realities of diverse teen athletes are much less represented. As a result, the model often struggles to provide recommendations that are truly culturally relevant or practical. This creates a potential equity concern. Some groups may receive advice that is less aligned with their cultural background, food environment, or daily circumstances than others. We also found that many plans assumed easy access to fresh ingredients, refrigeration, and time for meal preparation, assumptions that may not hold for many student athletes. Overall, our findings suggest that future AI nutrition systems need to incorporate richer contextual information, including cultural and socioeconomic factors, to ensure recommendations are not only nutritionally sound, but also practical, equitable, and relevant to the people they are designed to serve. There are some real limitations to this work that I want to be upfront about. We used synthetic personas, not real teen athletes, so we can't say exactly how this affects real people. We only evaluated 1 day meal plans. Our cultural categories were broad and can't represent every community. We didn't compute formal inter-rater reliability statistics, which future work should do. But here is what we can say. Across 288 nutrition plans, we found a consistent and significant pattern. ChatGPT is good at physiology and weak in cultural and practical context. The 54-point gap is real and concerning. The five-dimensional rubric we built could also be reused by other researchers studying fairness in AI health tools. That's one of the contributions I'm most proud of. Thank you so much for listening, and thanks to my mentor Lavanya Prahalad for her guidance throughout my project.